We stream high-definition video, run virtual meetings, and transfer massive datasets in seconds, often without a second thought. All of that activity relies on FTTH, or fiber to the home, hair-thin strands of glass carrying pulses of light directly into private residences. Across Ontario, the demand for this connectivity has surged exponentially. This visualization of broadband density leading up to 2021 shows intense heat map clusters spreading rapidly from major urban centers into the surrounding regions. Expanding this network presents an immense logistical challenge. Engineers must navigate the crowded utility corridors hidden beneath dense urban streets, while also stretching fragile glass lines across hundreds of kilometers of unpredictable rural landscape. Laying new fiber at scale involves a multi-layered spatial and regulatory puzzle, where every meter of cable must be reconciled against the physical constraints of the existing grid. Falconlights OSP Telecom Design Corp assembled its team in the first quarter of 2021 to address this specific bottleneck in Ontario's infrastructure rollout. Every design the team produces is strictly governed by rigid customer standard operating requirements. This schematic, layered with technical mandates and red warning stamps, represents the absolute constraints that dictate where and how a network can be built. Violating these requirements carries heady consequences. A miscalculated design can lead to catastrophic network failure, or require massive financial outlays to tear up and replace non-compliant sections of the plant. This creates the central challenge for a new design firm. They must deliver rapid network expansion while operating within a zero-tolerance technical environment. At a microscopic level, these customer protocols dictate specific variables for every project. This includes mandatory routing boundaries and the exact environmental limits a cable can withstand before the signal degrades. Capacity management is defined by the physics of the medium. This mainline cross-section isolates individual glass strands with strict data flow thresholds. Regulations are most intense at splice points, where fibers physically connect. These vulnerable junctions are subject to the strictest oversight. Technical governance functions as a rigid mathematical formula, where the margin for error is effectively zero. To solve these puzzles, Falconlights uses a structured outside plant design process. It begins with gathering raw spatial data, mapping every utility pole, every underground pipe, and elevation changes in the neighborhood. Engineers then translate that raw topography into a preliminary routing pathway, establishing a theoretical line from the data hub to the home. This leads to the friction phase, where the preliminary design is cross-referenced against the customer's operating manual. This reveals the inevitable violations, where a theoretical line might conflict with existing local infrastructure or safety codes. The team recalculates. They adjust cable depths, modify angles, and relocate splice points until glowing lines lock into perfectly aligned pathways, satisfying every requirement. Once every conflict is resolved, the team delivers the final blueprint, moving the project from a theoretical model to an executable construction plan. Falconlights produces the flawlessly compliant blueprint, the specific mathematical roadmap that makes physical construction possible. Standardizing this rigorous compliance process allows for rapid, repeatable network deployment across vastly different communities. By mastering these uncompromising standards since 2021, the company has built a framework to scale its operations in lockstep with the province's needs. The demand for fiber is only increasing. This chart projects the exponential growth trajectory for required FTTH connections in Canada through the next decade, showing an infrastructure boom that is just beginning. The next era of expansion will be defined by the firms that can successfully marry deployment speed with absolute technical governance. Ultimately, the speed and reliability of our digital lives depends on this unseen layer of meticulous engineering and strict adherence to technical standards.